Hello friends. So now we are moving to problems related to the true shapes. So the problem is a cone of base diameter 60 mm stands upright is cut by a section plane such that the true shape is a parabola of maximum double ordinate 50 mm and abscissa 70 mm. Maximum double ordinate 50 mm and abscissa 70 mm. Draw the front and top view and the true shape of the section. What is the inclination of the section? Now listen, it is given that a cone of diameter 60 mm. Before that, consider a cone. This is it. So, what are the sectioned images of a cone? That is called the conic section that you have studied in your plus 2 classes. So, what are the different conic sections? One is a circle. How we can obtain a circle? A circle can be obtained by intersecting a cone by a section plane which is parallel to the base. That means if you are cutting by a section plane parallel to the base, the resulting section will be a circle. Right? Resulting plane will be a circle. Now, if we are intersecting the cone by a section like this, so that section intersect both the generators of the cone, then the resulting section will be an ellipse. Okay, the resulting section will be an ellipse. Now, if we are sectioning or cutting a cone by a section plane parallel to the generator, then the resulting section will be a parabola. Okay, and if you are intersecting a cone like this, that means a section plane perpendicular to the ground, the resulting section is known as a hyperbola. That problem we will do that problem later. If we are cutting a cone by a section plane which is passing through the apex of the cone in this direction, which is perpendicular to VP as well as perpendicular to HP, that means a profile section plane, the resulting will be an equilateral triangle. Okay, we can also cut like this. This also result hyperbola, and if that section plane is perpendicular to both HP and VP, the resulting hyperbola, that means a hyperbola obtained from this is called a rectangular hyperbola. So this will give a circle, this section will give you ellipse, this section will give us a parabola, that means a section plane parallel to the generator. This will give equilateral triangle, rectangular hyperbola and hyperbola. Okay. So, in this question it is given that a cone of diameter 60 stands on the ground and it is intersected by a section plane, so that the resulting parabola has a double ordinate of 50 and an abscissa of 70. So, what do you mean by the term double ordinate and abscissa? See, if this is a parabola, this distance, the distance along its x-axis is known as abscissa, and this is the double ordinate. Here it is 50. So this is what is given. Okay. So in this question it is given that the abscissa is 70 and double ordinate is 50. Now listen. You can start. This is the XY line. Now, draw a circle of diameter 60, which is the top view of the cone. Divide it into 8 equal parts. Label. Okay, the center. Now there is a problem. The problem is the height is not given. The height is not given, which means we can only draw this much portion as of now. So we have a plot the diameter circle of diameter 60 and projected over dash. Since the height is not given, we cannot draw beyond this point. Now it is given that the true shape is a parabola of abscissa 70 and double ordinate 50. What does it mean? See, we know that abscissa is the distance along xy line, and double ordinate is the distance along y direction. Okay, which means if we are able to obtain the top view of the section, then this 50 will be same in the top view, because this is along y-axis, lying along y-axis. Clear? So, if we are able to obtain a height 50 here, we can obtain the double ordinate. We can obtain the double ordinate, or we can mark the double ordinate here. Right? So, from this line, draw a line at a distance of 25 upwards as well as downwards. You understood? So that this distance will be 50. Okay. So this distance will be 50, means this point is the starting point of the section plane. Understood? Because since this is the point on the section plane on the base, then that's why we obtained a section like this. See, this height is 50 because it is given that the double ordinate is 50. Through that, we obtain 2 points, one about upwards 25 and downwards 25, so that we have obtained this as 50. So we have obtained the starting point of the section plane in the base. One more data is available in the question, which is 70. What that 70 means? What does that 70 mean? Yes, it is the length of the section plane. See, the distance given along the x-axis will be the length of the section plane. So, in this case, this 70 is the length of the section plane. Okay, that is the length of the section plane. So, if we know that this is the starting point of the section plane, and the end point of the section plane will be at a distance of 70 from here, and it will be on the generator of the cone. Because I have already explained that for obtaining a parabola from a cone, the section plane should be parallel to one of the generators. Then only we obtain a parabola. Now listen, we have obtained this point. And if we are able to obtain this point, then we can draw this portion, right? How we can obtain? See, there is a property for the cone, and the property is this value should be equal to this value. This value should be equal to this value, right? Which means, if this, for this case, for the problem of, for this problem, if this is 70, this distance should be also 70. Okay? If this is 70, this distance should also be 70. Which means, we have obtained this point in our question, that is lying here. And we have the value of this distance, that is 70, length of the section plane. And we have this position also, it is here. Which means, take a compass, take a radius of 70, point it here, or make this as center, draw an arc at a radius of 70, intersect this arc by taking the same radius 70 and keeping this, so that we will get this point. Correct? Understood? This is 70, this should be 70, so that we have obtained a point here. And now, if you extend this line, that line will meet the axis here. Which means, this should be the apex. See, we have the axis with us. We have a point on the generator, because that is obtained by intersecting two arcs. Then, if we extend this line, it will intersect the axis at a point here. That will be the apex of the cone. Now we have obtained the height of the cone. So, we can complete the cone. So, this is the cone. This distance is 70. Okay. Now, we have the section plane with us. See, this is our section plane. vertical trace. We have the generators with us. This is a generator, this is a generator, and this is another generator. Right? So we can see that this generator intersect one point here, that is 1 dash. This section plane intersect this generator at one point, that is 1 dash. 2 points here, one at generator through B and another at generator through H. So 2 dash, 3 dash. Here it is 4 dash, 5 dash. And here it intersect at the base, right? So 6 dash and 7 dash. So we have obtained the intersection points in the front view. Now what we have to do? Transfer these points in the top view. How we can transfer? See, this is 1. Transfer this like, so that this will be 1. Transfer this 2 and 3 on the corresponding generators. These are the 2 generators. So this will be 2 and this will be 3. How can transfer 4 and 5? We have already done a problem like that. Transfer this point to the one of the generators, one of the rightmost or leftmost generators. Transfer that point to the corresponding generator. This is O1, O2 dash A dash. So transfer it to O2A. We have obtained a point here. Keeping this as center and this as radius, rotate. So that we have obtained 4. Take this distance or rotate in this direction. We will get 5. So we have 1 with us, 2 with us, 3 with us, 4 with us, 5 with us. So these points are already we have obtained 6 and 7. So we have obtained the top view. Understood? We have obtained the top view. Now what will be our next step? Draw a line. Parallel to the section plane. Draw perpendiculars or normal from all the points. Take this distance, mark here for getting 7. Take this distance, mark here for 8. Then take this distance and mark here for 5. Then take this distance and mark here for 4. Similarly, we can get another 2 points, 1, 2 and 3. So this will be the true shape of the section. And if you measure, this will be 50 now. This will be 70. This is a diameter of 60. This is 50. And this is radius 70. Now you can measure this value. That will be the height of the cone. I think that has been asked in our question. So that will be the height of the cone that you can write here. Also you can measure the angle of inclination of the section plane. That also can be mentioned in your answer if it was asked. Okay. So I hope all of you have understood. Okay. I will explain again. First, it is given that a cone of diameter 60. So draw the circle. Divide the circle into 8 equal parts. Label it. Project in the front view. Label A dash to H dash. Look at the center O1 and O2, O1 dash. But since there is the height is not given, we cannot obtain the apex. We only can draw the axis. So we draw the axis. Now we know that for obtaining a parabola from a cone, it should be intersected by a section plane parallel to one of the generators. So this should be our section plane. And it is given that the true shape of the parabola is abscissa 70 and double ordinate 50. This is the double ordinate and this is the abscissa. So we can see that the double ordinate 70 is lying along x-axis, abscissa is the double ordinate 50 is lying along y-axis, and abscissa is lying along 70 is lying along x-axis. So this 50 will be same in the top view, and this 70 will be the length of the section plane. Okay. So take this 50, locate the 2 points on the circumference of the cone at a distance of 50. How we done it? See, from the center, draw a line parallel to this center line at a distance of 25 upwards as well as in the downwards, so that it intersects the base at the 2 points. So we have obtained the starting point of the section. If we project here to the base, we have obtained the starting point of our section plane. Now, for a cone there is a property, and the property is this distance will be equal to this distance. So in our case, we have this point corresponding A dash. We have this point here. We have this value, length of the section plane as 70. So keeping this point as center and radius as 70, draw an arc here. Keeping this as center and the same 70 as radius, intersect an arc here, so that we have obtained this point. Which means we have obtained the section plane. Draw the section plane. Now, if we extend this line, that line will meet the extension of the axis. That line will meet the axis that we have already plotted, so that that point will be our apex of the cone. Now we can complete the cone. We can draw the corresponding generators. This section plane have intersected the points on the generators. So locate those points as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash and 7 dash. 6 dash and 7 dash are on the base. Transfer the corresponding point in the top view. You will get the top view. Draw the true shape as we have done in the previous questions. I hope all of you have understood this question. Thank you.